Hello, hello, hello. Welcome, everybody. Hopefully you can all see my face and my screen. If I make my PowerPoint go full screen. Hello. Welcome, welcome, welcome. Nice to have everybody here. Please feel free to say hi in the chat. It's lovely to have people here. This is our A-level chemistry web class, one of our Sunday sessions. So this one's chemistry. We're going to have a look at a web class on the rate equation. So yeah, please feel free to say hi in the chat. Hello, hello, hello. Welcome. I'm going to have a go at pronouncing names, so apologies if I get it wrong, but welcome to Illegal Foul. Hi, nice to have you here. Please feel free, if you haven't already, to download our lesson PDFs. Hi, Kat. Hi, Ikra. Welcome back. Nice to have you guys here. Yeah, if you haven't downloaded today's slides, please do this. Really, really useful. You can keep hold of them for revision. You can go through them now, annotate them now as we go along. You can do both. You can download both here. The link is in the chat for you. Hi, Salsa. Nice to have you here as well. Welcome. Please feel free to ask as many questions as you can as we go through the lesson. I'm going to do my best to keep my eye on the chat. If I miss a question, please feel free to put it in the chat again and I'll try and get back to it. If you know the answer to someone else's question, then please answer, because one of the best ways to learn is by teaching. So if you want to have a go answering other people's questions, then please do. And I can check, we can chat through answers together as well. Castaneda, nice to have you as well. I think I recognize some of these names, so it's nice to have you guys back again. But welcome if there's anybody who this is their first time. So we have Sunday sessions, most Sundays actually. So we offer maths, physics, chemistry, biology Sunday sessions, and where we cover little revision web classes on content that hopefully you're familiar with, or if you're not, then we can introduce you to it. We cover all the main exam boards. We look at OCR, AQA, and Edexcel. And so we cover all the content that links those guys, or that is the same amongst those guys. Okay, I think we are probably about ready to get started. So the more you guys get put into this, the more you'll get out of it. So please ask and answer as many questions as you can. I'll try and give you time to answer, but please have a go. If you don't know, that's absolutely fine. Have an educated guess though, because it's always better than not guessing at all. Okay, so a little bit about me. I'm Alyssa. I've been doing these lessons with SnapRevise now for, it must be coming up to a couple of years now, which is fabulous. I'm the lead chemistry teacher at SnapRevise, and I've got a PGC from Oxford, and I can teach all three sciences, but chemistry is my favourite. And I've been teaching A-level chemistry now for the last 7 years, so for a long time, but I love it. I think it's great. So let's have a look at this lesson. So in our objectives for the lesson, what we're planning to do is to understand the rate equation and rate constant. We're going to understand differences in order of reactions, and we're going to determine the rate equation using experimental data from initial rates in a table. That bottom one is one that lots of people find very hard to do initially, but it's one of those, what we sometimes call a meerkat moment, or like a eureka moment, where once you get it, or once you can follow the question, they become so much easier. So we'll have a go at a couple of those. We can see how many we can get through. We may not have time to do very many, because if there's lots of questions or lots of chatting through theory, we may not have a huge amount of time to do all of the exam questions, but we're going to give it a go. We're not going to look at units of rate equations, although if that is something that you want to have a look at, then please do. And we're also not going to look at graphs. That's actually something that SnapRevise covers in another web class. Okie dokie, at the end of this session today as well, I will be talking about our seminars. So if that's something you're interested in, then please hang around. At the end, we're going to talk about our seminars that are coming up in the Easter holidays. Okay, so you guys should be familiar with which exam board you are a part of, or you're following. So this is our AQA. These are the specification points from AQA. So if this is your exam board, then just double check you're confident with what's expected of you. This is Edexcel. These are the specification points from the Edexcel scheme of work, from specification, sorry. So this is what's expected of you. And this is OCR. Again, this is what's expected of you if you're an OCR student. The specifications are one of the most useful, I think, and least used resources at A-level. So get your I would get really familiar with your specification. Some of the exam boards are better in some areas than others. Some are more descriptive than others. So if you get confident with your exam board and what's expected from you, you can almost use it like a checklist. This is what they expect you to be able to do when you take your exam. So they're really, really useful. Will there be a session that covers graphs at some point? I am not sure what sessions we've got coming up. It's worth having a look through our back catalogue though, because there may have been a session on graphs. It won't be live, but a recording of a session on graphs. So please feel free to have a flick back through our older videos and see if you can find one. There may have been one, because we have been doing this for a while now, so we may have covered one. If not, there's the potential it's coming up, but I don't know, I'm afraid. I can't give you a definite answer on that. Okay, so let's have a look then at what we hopefully already know. So definition of rate. I don't want a rate expression or a rate equation. What is definition of rate? So Ilyas, we look at all three exam boards. So we cover content that is covered in all three exam boards. And if there's anything that's specifically different, then I will highlight it to you to say, oh, if you're OCR, you don't need to do this. Or if you're AQA, you're the only one that needs to do this. Okay. But we do try and make sure our content is applicable to all three exam boards. Okie dokie. Lovely, Cat. Good. And fabulous random facts as well. So good. So our rate is a change in an amount of substance, or it's how fast or slow a reaction takes place. And we can write our theory in terms of it's the change in something, whatever we're measuring, the change of something. And in terms of chemistry, we tend to do the change in concentration of a product or reactant. Actually, I'm going to put all. And then it's over a specific period of time, or within a specific period of time. Very good. Yeah, well done, guys. Thank you very much, Sarah. That's great to hear. Thank you. Lovely. And the person who said about Arrhenius equation, again, please look back through our back catalogue. There might be one. So please feel free to have a look back through our back catalogue of videos. There may be one that we've already done on Arrhenius. It is a web class that we have. So if you're interested, then please feel free to head over to our website, and you could join us on the website, and you then have access to many more web classes, if that's something that you're interested in. Okie dokie. What does this funky square bracket symbol mean? What does that funky square bracket symbol mean? And it's something you get used to seeing, and now, because I've been looking at it for years, it's really easy for me. But if you're not confident with it, get confident with it, because this comes up a lot. Good. It means concentration. So brackets around A means concentration of A. And that's something that I will say casually, but if you're not comfortable with that, with the brackets meaning concentration of, then like I say, practice, 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 because it means concentration of whatever's inside the brackets. Really good. Well done, guys. Looks like we've got loads of people contributing, which is fabulous. Well done. Okie dokie. So part one, the rate equation. Like I say, the more that you contribute, the better. The more you'll get out of it. Just for a bit of fun. Why not? Why not a squirrel? Okay, so we've got to keep it fun, haven't we? We've got to try to anyway. Okay, so let's think about this reaction then. We've got a reaction A plus B goes to make C plus D. So if A plus B goes to make C plus D, we could write a rate equation or rate expression that said rate is equal to K times the concentration of A times the concentration of B. What does K mean? I've written K, lowercase k. What does that mean? What is lowercase k? What does that mean? What was it? So this is supposed to be a lowercase. I'm going to put a little tail on that one. So it's a lowercase k. What is a lowercase k? Good. Well done. Fantastic. Pretty, yeah, well done, guys. Rate constant. So K is the rate constant. And what does that describe? Can anyone, it's not an easy thing to describe, but what is it? What's the rate constant? Why have we got it in this equation? What's it doing? How's it helpful to us? What does it do? Does anyone know? It's not a very easy thing to describe, but what is it describing? The speed of a reaction? Yes. Oh, ChemMed, yeah, that's quite nice as well. So it's including other factors that affect rate. So it was not quite the direction of reaction. That's a good idea. Yep, it is specific to a temperature. Good. I think everyone kind of knows what it is, but it's a very difficult thing to describe. So the rate constant is a constant. It's a value that can link the rate of an equation to the concentrations of reactants that affect the rate. In this case, I've said that both A and B affect the rate, but K is a constant, a numerical representation or relationship between rate and the concentrations of reactants. Very nice, Anna. Yeah, brilliant. That's almost exactly what I'm about to write down. So K shows, if at any point you can't read my handwriting, by the way, please tell me and I'll rewrite it. So K, it shows the numerical relationship between rate and the concentration of A and the concentration of B. Good, fantastic, well done. Okay, so let's move on to some simpler versions of rate equations, some simple rate equations. So in order to do that, we need to think about the orders of reaction. So we've looked at rate equals K, the rate constant, times the concentration of A times the concentration of B. This rate equation that we've just written suggests a directly proportional relationship by a factor of 1 between the rate and the concentration of reactants. What we mean by that is if the rate, actually no, let's do it the other way around. If the concentration of a reactant increases by 2, because its rate is equal to a constant value times the concentration of A, if we double A, we have to double the rate. So this is a directly proportional relationship. If we double A, we double the rate. If we were to triple the concentration of B, we would triple the rate. It's a directly proportional relationship, and that's what we're representing here. So it means that I'm going to write those two down. If we, if the concentration of A doubles or times is by 2, then the rate will times by 2. Or if the concentration of B times by 3, we can use any number here, times by 100, then the rate times by 100, okay? Whatever we've done to the concentration of our reactants happens to the rate. That's directly proportional and exactly right, XP Master as well, you've just said. If it does happen, if as we double the concentration of A, we double the rate, or triple concentration of something, we triple the rate, we call that a reaction order of 1 or first order. Very nice. Okay. It comes from this rate equation, okay, and it comes from the relationship between rate and the concentrations of these reactants in the rate equation. So for first order, we say the rate is directly proportional, so that's like a sideways fish, directly proportional. It looks very much like my and symbol, so they are different, so that's the directly proportional. So rate is directly proportional to the concentration of our reactant, and it's to the power 1, that means itself. This is where we get the number 1 from. Order 1 is because it's the concentration to the power 1, okay? So first order, if, oops, just put a line through it, if the concentration of A has times by 5, then what happens to the rate? If it's a first order with respect to A, or with respect to the concentration of A, and I times by 5, I times the concentration of A by 5, what's happened to the rate? What would happen to the rate? Anyone want to tell me? I'll come to those questions in a second. Very good questions, but we'll come to it in a second. Good, well done, those of you that, yeah, fabulous. The rate is times by 5 because it's the rate would be times by 5 to the power 1. 5 to the power 1 is just 5, so it's just 5 times bigger. Whoops, I'm just drawing a line through it as well. There we go. Lovely. So just to go back to those questions, no, you're absolutely right. None of the exam boards expect third order, but we're just showing you that this relationship, I think it's a lot clearer when you understand how the relationship works. Technically, you could have a reaction which is 8th order, which is 100th order. You're not going to see that at A level. We only ever go 0, 1, and 2, or 0th, 1st, and 2nd, but it is possible. And we're just showing you the pattern, basically showing you the trend. Okay, let's think about second order then. This number 2, second order. So in this case, the rate is proportional to the concentration of A squared. The rate is proportional to the concentration of A squared. Again, that's where this number 2 comes from, where the second bit comes from. So if, let's take our concentration of A and let's times it by 3 this time. I'm going to use all sorts of different numbers. I've times the concentration of A by 3. I've increased the concentration of A by 3 times. What happens to the rate? The rate does what? If it's second order with respect to A, and I've times the concentration of A by 3, what's happened? Oh, smashed it. Lovely, really good. Well done, guys. So it would be 3 squared, that's where the 2 comes in, which is 9 times bigger. The rate would increase by 9 times, so we've increased the concentration of A by 3. So 3 squared times bigger for the rate. Which sign? The proportional sign, do you mean? Illegal foul, is that what you've asked? The proportional sign? Or the concentration sign? Next to rate, yes, proportional to. So in terms of this is showing how, if you were to times it or if you were to divide it, what you do to one you have to do to the other. They are directly proportional. Yeah. Okay, and then we might as well practice. If we have the rate is proportional to the concentration of A to the power 3, so it's third order, and just saying you don't have to know this for A level, but we might as well because it's a fairly straightforward concept, and I think it's nice to see the trend. So if we take the concentration of A and let's times it by 5 again, if I take the concentration of A and times it by 5, it's third order with respect to A. What will happen to the rate? What do we think happens to the rate? Good. So we've got a couple of different answers, but most people are saying 125. So follow the same pattern. The rate would be times by 5 cubed. It's third order. Third order rate is proportional to whatever happens to the concentration cubed. So the rate will be times by 5 cubed. Now 5 cubed is 125. 5 times 5 times 5. Very good. Well done. And it carries on like that. Same pattern. Fabulous. Well done, guys. Okay, let's keep going. I think most of you will probably be confident with this bit, but we will just double check. So you may be asked, and you do have to pay attention to the exam questions, but you may be asked to calculate the overall order of a reaction. So in order to calculate the overall order of a reaction, what's the overall order of this reaction here? For example, rate is equal to K times the concentration of HCl squared times the concentration of ethanol. What's the overall order there? Nice. Lots of us saying 3. What we've done there is we've taken the order of the reaction with respect to hydrochloric acid, which is second, and we've taken the order with respect to ethanol, which is 1, but being lazy chemists, we don't always write the 1 in, and we've added them together. So the overall order is 2 plus 1, which is 3. That is third order for the overall order. So this is not one specific reaction. This is the whole order. Really nice. Well done, guys. Okay, when the concentration of a reactant has no effect, when it has no effect on the rate of reaction, what is it said to be? Good. Zero order, fantastic. Zero or zeroth. You can say zero or zeroth, it doesn't matter, but zero order. Zero or zeroth order. And just to link it back to the previous page, it's the same concept. If it was first order, then the rate is proportional to the concentration of A to the power 1. Because this is zeroth order, the rate is proportional to the concentration of A to the power 0. And those of you who do maths may know anything to the power 0 is what? Anything to the power 0 is 1, exactly. It's 1. So you're basically saying the rate is itself, is proportional to 1. So it doesn't matter what we do to A, we can change, we can make A as big as we want, we can make it a billion, but because it's to the power 0, it's always 1. So it doesn't matter what we do to the concentration of A, it's never going to change the rate. Okay, A to the power 0 is 1. Anything to the power 0 is 1. So it is zeroth order, or 0 order, has no effect. Lovely, well done, guys. Okay, how are you feeling confidence-wise? Give me a 1 or a smiley face if you're feeling, yeah, actually I was quite happy with all of that, feeling pretty confident. Give me a 2 or a medium face if, yeah, it was okay, maybe I'm going to need to go over it again, or I'm not feeling too confident about maybe doing some exam questions, but that seemed okay. Or you can give me a 3 or a if you're super confused, maybe it's the first time you've seen this and you're not happy, you're going to need to go over it a few times. Awesome, okie dokie. It doesn't matter, of course, wherever you're at. This is as much for you as it is for me, so you to gauge how you felt about that. Do you think you want to do some more revision? Are you going to need to go over this again in a week's time or a month's time, etc.? Nice, lovely. And don't forget, you can always go back and rewatch this web class in a week or so's time just to remind yourselves of everything. Lovely. Okay. Yes, it would, Ken Medic. That's a good question to ask. So if it was zeroth order and we wrote a rate equation where they were all zeroth order, then it would just rate would equal K. Yeah, good. Just equal the rate constant for that reaction at that temperature. Very good. Okay, so part 2, our initial rate calculations. Let's have a go. So this is a typical set layout of an exam question that you would get. It's something that we have to get confident with. And like I said at the beginning, this is something that is a lot easier to do once you've had practice and once you've had, often when you've had a eureka moment or like a meerkat moment, you go, oh, that makes sense. Then they become a lot easier. So power through. If there's something you find difficult, power through and we'll get there. And obviously feel free to ask as many questions as you need. We'll go through this this first couple of questions and then we'll see where we're at with time. Okay, so the following initial rate data was obtained for the following reaction. So we've got 1 lot of HCl plus 1 lot of ethanol makes 1 lot of water and 1 lot of chloroethane. Determine the rate equation for this reaction. So in order to determine the rate equation for this reaction, there's no way to know, we have to use our initial rate data. Anybody know what the first step is that they would do if they were presented with a table like this? What would you be looking to do? What's the first step in a question like this? Good, we want to find the order of each reactant, and we do that by comparing trials or comparing experiments. Sometimes they're called trials, sometimes they're called experiments, etc. Lovely. Kat says find 2 for the same reactants that are the same. So we find 2 trials where at least one of the reactants stays the same. This is because, well done XP, we'll check and see if you're right in a second. This is because as with normal experiments, you can only change one thing at a time in order to be able to draw a solid conclusion from it. So if we compare trial 1 and trial 2, we notice that we've kept the concentration of HCl the same between those 2 experiments. In the first experiment, our concentration of ethanol was 3.3, but in the second experiment, we doubled it. We upped it to 6.6. Now, the way that I lay this out might not be the best for everybody, so please feel free to use your own way. But what I do is I say, right, what's happened between trial 1 and trial 2 for HCl? Nothing, we've kept it the same. What's happened between trial 1 and trial 2 for ethanol? Well, we've doubled it, so I'm going to put in a times by 2. I've told myself I've doubled the rate, doubled the concentration, sorry, of ethanol. What's happened to the rate? As I doubled the ethanol, the concentration of ethanol, what's happened to the initial rate between trial 1 and trial 2? What's happened to the rate? Anybody know? Good, the rate has doubled as well. The rate has times by 2 as well. So this is when we go back to thinking about our orders. What does that mean? So if my concentration of ethanol has doubled and the rate has doubled, what order is it? What order is it? The same thing. They are directly proportional, and therefore it's first order. Very good, well done. Therefore, the reaction is first order. Oops. And I'm going to be really lazy just to save me time, but please don't feel like you need to be. WRT means with respect to. So it's first order with respect to our concentration of ethanol. Okay, I'm going to be nice and lazy and leave that in. Fabulous. I'm going to change color just so that we can make it a little bit clearer. I'm going to change to red. Next step then, we've worked out the order of reaction with respect to ethanol. What's the next step in our question? Excuse me. What can we do next? How can we, what's the next step in our question or in our determination of the answer? We compared trial 1 and 2. We used ethanol. It'd be better now. Good. We want to look for the order of HCl. We want to see if we can compare HCl. And so the easiest thing to do, again, I'm looking at what information I've been given. Here, I can see that I've kept the concentration of ethanol the same between experiment 2 and experiment 3. And what have I done to HCl? So there, I've kept ethanol the same. What have I done to HCl between trial 2 and trial 3? Good, I've doubled it. Okay. What effect has this had on the rate? Again, HCl is the only thing that's changed. So whatever happens to the rate must be a directly caused by what we did to HCl. So what's happened to the rate? What has happened to the rate? And for those of you maybe who can't see it, sometimes we can see it. I don't know, I could see that our rate between 1 and 2 had doubled. I could see that doubled because I could see with the numbers. You might not be so confident about that. So what we can do, just to make it easier on ourselves, is divide the bigger number by the smaller number and see how they're related. And they're related by 4. That means I've times the smaller number by 4 to get to the bigger number. Good, well done those of you who can see that or have worked that out already. So I've times, or the rate, sorry, I haven't, the rate has increased by 4 times. So let's write that out. Concentration of HCl was doubled, but the rate has times by 4. So what order is this with respect to HCl? What order are we looking at then? Really good. Second order, let's just double check. And it absolutely is second order because we look at what have we done to 2 to get it to 4? We've squared it. We've squared 2 to get it to 4. So that means we're looking at second order. So therefore, it is second order with respect to the concentration of HCl. Whoops, make sure that's a proper concentration bracket. Really nice, well done. Let me know if anyone's not happy with that. Have we finished the question? Have we finished the question? Have you not, Neve? It is definitely part of the AQA syllabus. Yeah, rates and orders of reaction. If you flick back to the beginning of the PowerPoint and just have a look, it should say whereabouts in the AQA syllabus it is, and you can go look it up. Good, well done, those of you. So often students get to this point and think, oh, I've finished. Don't forget to go back and reread the question. Have you answered it? And the question says, determine the rate equation. Okay, so we need the rate equation. We just need to learn or remember that rate equation is the one that we say rate equals. So what is the rate equation? Rate equals in full. What are we thinking? Rate equals. Just double check that you've included everything you need to include. Good, well done. Lovely. Now, it doesn't matter which way around you write it. You can write it either way around. It's entirely up to you. But we just need to make sure we've put the squared for HCl because it is second order. That's where we get that little squared number from. So I'm going to put it first, but like I said, it doesn't matter. I'm going to put HCl squared and then ethanol to the power 1. Now, you don't need to write in the 1. We can leave it blank because we know the 1 is there. Mathematically, we know the 1 is there. Oh, and I didn't put K, even though I said it. K times concentration of HCl times the concentration of HCl squared times the concentration of ethanol. In these questions, you do need to put in the chemicals because you've been given the chemicals, so you can't unfortunately put A and B. You do need to write the correct chemicals in. And don't forget, as I just did, to put the K in, put the rate constant in. Square brackets. And yes, ChemMedic, exactly right. The overall order for this reaction would be 3. Well done. Oh, Neve, yes, it is year 13 or second year, A2. Yeah, that'll be why. If you wrote the 1, would it be marked right still? Yes, absolutely it would. You just don't have to, and we're being lazy. Lovely. Okay. Fantastic. Right, let's try another one, shall we? We're going to step it up a little bit. We're going to go a little bit harder. So, the following initial rate data was obtained for the following reaction. Please feel free to go ahead, but if you get stuck, then you'll have to catch yourselves up, and that's fine. So if you want to go ahead, then please do. I'm going to take it nice and slowly, step by step, to get to the answer. So the question asks us to determine the rate equation for this reaction. So first things first, what are we looking for? First things first, what would you do? What would you do? What would be your first step in answering this question? Which ones are you going to compare? What are we looking for? Good, we're going to compare some trials. Anything jump out at you? What could we work out first? Anything looking positive or looking promising first? Cry. No, don't do that. You've got it. I'm sure you've got it. Good. Yeah, lots of people are saying compare 1 and 2 and to work out sodium hydroxide. I think that's a very good idea. Often at A level especially, they like to lead you through it. So usually the best thing to do is start with 1 and 2. Not always, but usually. So feel free to start with 1 and 2 if you're not feeling very confident. And if it all goes pear-shaped, then you can try something different. But usually starting with 1 and 2 is a good idea. Okay, so I'm going to compare trials 1 and 2. It's a really good place to start because we've kept the concentrations of aluminium oxide and water the same. Because of that, we know that they aren't going to have any effect on the initial rate that we measure. So the only thing that's going to change the initial rate is our concentration of sodium hydroxide. So that means we know exactly what effect it has. Okay, what have we done then? What have we done to the concentration of sodium hydroxide between trial 1 and trial 2? Between experiment 1 and experiment 2, we have done what? Lovely, Simone, brilliant. And Kat, very good. Well done, Khadija. Yeah, brilliant. We're timesing it by 2. We've doubled it. I like to use numbers, like words I may say doubled, but I'd like to write down the numbers just because then it's easy for me to see the patterns in the numbers. But yeah, as long as we all understand it, then that's absolutely fine. Good. So we've doubled the concentration between trial 1 and trial 2. And what's happened to the rate? What impact has that had on the rate? Again, if we're not sure, we can check using numbers. So if I do the bigger number divided by the smaller number, or the second one divided by the first one, is probably a better way of thinking about it. And what have I had to do? I've had to times that first number by 4. I had to times it by 4 to get to the bigger number. Good, so it's quadrupled. So let's write that down then. As my concentration of sodium hydroxide has doubled, what impact has that had on the rate? The rate has times by 4. So what's the order of reaction? Good. It is second order. And I'll just show you the relationship. It's because it's times by 2, which is what we've done to the concentration, squared. Remember, if it's second order, the rate is proportional to the concentration of whatever it is, in this case, sodium hydroxide, squared. So if we've doubled sodium hydroxide, then we've doubled squared the rate, which is 4. Good. So it's second order with respect to sodium hydroxide. Really good. Well done. Okay, next one. So that's only one of them. We've got another 2 to do. Which one looks more, looks like a positive one to do next? I'm going to go to green. Let me know if you can't read it in green. Hello, hello. Welcome. If you're only just joining us, please feel free to have a go and join in as much as possible. Good. Yeah, lots of people are saying let's compare trials 2 and 3. Again, they like to lead you through it. And as I can see, they've kept the concentrations of sodium hydroxide and water the same between trial 2 and 3. So we know the only thing that's having an influence on the rate is the aluminium oxide. And just to speed things up, we have doubled the concentration of aluminium oxide. What impact has that had on the rate? We've doubled the concentration of aluminium oxide. Al2O3 has doubled. What impact has that had on the rate? It has doubled it. Good. Rate has also doubled. And then we can look at, wow, what's the relationship between these two numbers? Double and double. Well, it's 1. They're equal to each other, so it's first order. They're directly proportional, so it is first order. First order with respect to, again, I'm being lazy writing with respect to. In an exam, you should write it out in full. With respect to aluminium oxide. I realized I didn't write with respect to on the other one, did I? Naughty. Whoops, pressed a button. Go back. With respect to concentration of sodium hydroxide. Lovely. Anybody not happy with that? Because the final one, as I think someone's already noticed, is a little bit harder. We'll try, shall we? Let's try. So third order would be cubed. Yeah, exactly right, Neve. Yeah, exactly. Okay, colors, I'm going to go red. So let's compare trials 3 and 4. You don't have to compare trials 3 and 4. You could compare one of the other ones. But the reason I've chosen to do that is because it's kept sodium hydroxide. The concentration of sodium hydroxide has been kept the same. So I know that that hasn't had an influence on the rate. And that looks like a fairly easy number because what I've done with aluminium oxide is doubled it. So that's going to keep things a bit nicer. But like I said, you could do whichever ones you wanted, as long as there's only one unknown, then it doesn't matter. So the concentration of aluminium oxide has been doubled. What's happened to the concentration of water? You could do 2 and 4. That would work quite nicely, I think. 1 and 4 would be much harder. So only have a go at you doing it using 1 and 4 when you're really confident with these kind of questions. Yeah, lovely. So the concentration of water between experiment 3 and 4 has doubled. Well done. And our concentration of aluminium oxide has doubled. Now, take a step back from this. This is where the challenge comes in, I think. Take a step back from this and just ignore what we've just thought about and just tell me what's happened to the initial rate between experiment 3 and 4. What has happened between experiments 3 and 4? So ignore our reactants at the moment. What's happened to the rate? Yes, David, we could absolutely make an intermediate table, which we might do in a second if we feel we need it. Yeah. So just to double check, we can work out exactly what's happened by doing 1.18 times 10 to the minus 1 divided by 2.96 times 10 to the minus 2. 1.18 times 10 to the minus 1 over 2.96 times 10 to the minus 2 gives us approximately 4. Yeah, it is. It's not exact because we've obviously had to round a little bit, but it is 4. Yeah, I'm going to put approximately, but it is 4. The numbers are a little bit, rounded, but yeah, good. So it's approximately 4. Okay, so when we've doubled aluminium oxide and we've doubled the concentration of water, the initial rate has increased by 4. Now, again, we need to separate it out in our head. Ignore water. We know, because we've already worked out that aluminium oxide is first order with respect to, reaction is first order with respect to aluminium oxide. So if we ignore the fact that we changed water, if aluminium oxide was the only thing that had changed, we'd only doubled the concentration of aluminium oxide, the initial rate should have doubled. So the initial rate would have been, what would it have been? Let's work it out. 2.96 times 10 to the minus 2 times by 2 gives us, where am I going to write it? I'll write it here. Oops, 2. Sorry, my pen's being a bit slow. 2.96 times 10 to the minus 2 doubled. So if aluminium oxide was the only thing that impacted the rate, the initial rate would have been 0.0538. But it's not 0.0538. It's 1.18 times 10 to the minus 1, or 0.018. 0.118. Sorry, I misread that. 0.118. Yes, these videos are about an hour. Yeah, so we'll be tying up in about 10 minutes time. I'm going to need to go on time though, excuse me, because I've got a lesson on the website every Sunday. Lovely. So let's just get back to this. So if our aluminium oxide has doubled, the rate of concentration of aluminium oxide has doubled, we would expect the rate to have also doubled, but it hasn't doubled. It's actually times by 4. So what you can do is you can use this number as an intermediate, and you can feel free to write out a whole nother layer, a whole nother table, or another row on the table if you need to. This means that if we now think about what's happened to the water, as the water has doubled, it's taken the rate from 0.0538 to 1.18 times 10 to the minus 1. So that has doubled the rate as well. So if our concentration of water doubles, our rate has doubled. Therefore, it's first order with respect to water. Now, how many people are not confident with that step? Because if we've got lots of people that are feeling quite happy, we'll leave it, we'll move on to another exam question. If most of us are not happy with that step, then we'll go back and do it again. First order with respect to the concentration of water. Oh, yes, sorry, that's a very good point. We're using times 10 to the power so that you can compare them a bit easier, but you're right, I didn't do that here, and maybe I've confused things. Fair enough, Neve. Well, you're doing very well to keep up with it. Should we go over it again very quickly? And then we will move on. So I'm going to change color. I'm going to go orange so you can see my scribbles. What am I going to do? I'm just going to need to rub out the green, I think, just to move it down a bit, just to make it easier. Oh, although my pen didn't want to do that. Sorry, my pen's being nice and slow with the rubber. There we go. So what do we say? Concentration of aluminium oxide doubled. Rate has doubled. First order. That was my scribbling. Oh, that is bad handwriting. Try that again. First order. Okay, so what I'm going to do is I am actually going to draw in an extra little table, an extra bit to the table, which is basically going to do what I just did with the maths down there, just to make it easier. Let's go back to orange. So I'm going to make this experiment 4.5, 4.5. So I'm going to keep the concentration of aluminium oxide at 2. If I were to do an experiment, this is a theoretical experiment because I haven't done 4.5, but I'm going to pretend if I did experiment 4.5, I would keep aluminium oxide at 2. I would keep our sodium hydroxide concentration at 2.6, the same, and I wouldn't change the concentration of water. I would keep the concentration of water at 0.2. Okay, then I can, so I've got a bit of a sniff. There we go. So then I can compare what's happened here. This time I'm comparing 3 and 4.5. So in orange, I'm comparing 3 and 4.5. What have I done there? I've doubled the concentration of aluminium oxide. What would happen to the rate? Well, we know that it's first order from previous reactions we've just worked out, the one we did in green. We know that it's first order. That means if I double the concentration of aluminium oxide, I must double the rate. That means the rate at this point would become 0.0538. Then I can times it by 2. So Neve, I kept it at 0.2 so that I've kept it the same between 3 and 4.5. So when I'm comparing my trials, like I did earlier, I've only changed one thing, and the only thing I've changed is the aluminium oxide, just so that I can look to prove the effect on the rate, that's all. Yeah, illegal foul, that's exactly why there, just so that the only thing that has changed the concentration between, the only thing that's changed the rate between trial 3 and trial 4.5 is, well, actually should be 3.5, not 4.5, that makes more sense. Let's call it 3.5. Sorry, oh no, something's pressing buttons. There we go. So that I've kept it the same. So there's only one thing that has had an effect, and that is the aluminium oxide. Then I can compare trial 3.5 and trial 4 to do the same thing. And this time I'm going to have to go for blue, I think light blue. So let's compare trial 3.5 and 4. This time I've kept the concentration of aluminium oxide the same. I've kept the concentration of sodium hydroxide the same. I've doubled the concentration of water. So what effect has this had on the rate? It's doubled it. And this is to find the order of water. Exactly. So then we've only changed one thing. The only thing we've changed in our comparing 3.5 and 4 is the concentration of water. We've doubled the concentration of water, and therefore we've doubled the rate, and therefore it must be first order with respect to water. What we do is we create this little hypothetical reaction. You can either do it by drawing yourself out another line, another row on the table, or just by doing the maths behind it, but create yourself a little hypothetical situation. See what impact changing the concentration of something you know would have on the rate. Once you've worked out exactly what that impact would be, then you can see the difference between that and the actual rate you've been given. And that must be whatever the unknown is, that must be the effect from the unknown concentration. Okie dokie. Lovely. Okay, let's have a go then at an exam question. So let me know how you're feeling about this. We're feeling confident, not confident. It's absolutely fine, either way. Fair enough. No, that's absolutely fine. Make sure you're confident with the ones like the first one we did, the bit of the slightly easier one. And I put it in quotes because obviously chemistry is not easy. Just check that you're confident with that one. Once you're confident with that one, then move on to the harder ones, because you do need to be confident in orders and their effect on rates in order to be able to do ones where it's like a double step. Lovely. Cool. Fabulous. Lovely, guys. Awesome. Okay. No worries if not. You can always come back to this web class again. Make sure you've got our slides downloaded, etc. To have a go at. Right. We are going to see how far through this we can get in the next. Oh, actually, no, we are slightly running out of time. No, I don't. I'm afraid, actually, guys, I'm going to make an executive decision that I don't think we're going to have time to have a go through this. But what I will do for you is write out the answer. Okay, this is a slightly sneaky question because we actually have to use graphs to get some of our information. So what I'm going to do is I'm going to give you the answer to this question. Have a go at this on your own, and hopefully work through it until you have got your correct answer. So the answer for this one is rate is equal to K, the rate constant, times the concentration of CH3,2CO, our propanone, to the power of 1, times the concentration of HCl to the power of 1. Okay. Have a go. If you're not confident, take your time over it, double check everything, and then hopefully you will get yourselves to the answer. Go back through this web class as many times as you need, following the steps. Hopefully you'll get yourselves there. Okay, awesome. Right then, there's another one there, but we won't have a look at that one either. So what we've looked at is we've looked at the rate equation and rate constant. We've understood differences in orders of reactions, and we've determined the rate equation using experimental data from initial rates in a table. If you have any questions, please pop them in the comments. I'm just going to show you a little bit more information about our crash courses, our seminars, just in case this is something you're interested in. They're coming up in the Easter holidays. So if you're interested, we have exam crash courses for biology, chemistry, physics, and maths. There's a day on AS or year 1 and a day on A2 or year 2. We spend the morning usually looking at exam techniques and trickier topics. We give you an amazing seminar booklet to take home, and there's a tutor messenger app, sorry. It takes place either in Regent's University London, if that's something that you're able to get to, or we have a live stream option. So our exam techniques, so the morning sessions will be how to interpret exam questions. We go through a range of question types, helping you to see exactly what's expected from you from each of those exam question types. And we look at step-by-step approaches to answering the questions to get full marks in as many questions as you can. Then we're going to cover, and we've tailored these to the advanced topics. So then we're going to look at covering the concepts from the trickier areas of the course. So this is tailored to the advanced information that we got. And we use the exam techniques that we've done in the morning to answer loads of exam questions. We also get these amazing seminar booklets. These are awesome, awesome resources that you can take home. They're something that you complete throughout the day whilst you're on the course. We've packed them full of extras like mock papers for you to have a go at, topic tests, etc., as well as all the notes and stuff. So they are awesome, awesome resources, and a take-home resource for you. If you come in person, then we will give them to you on the day. If you are on the live stream, they will be posted to you, and that's included in the price of the live stream ticket. Also something that we offer throughout the seminar is a tutor messenger. So whilst we're going along, just as you guys have been chatting away happily in the chat here, we have a tutor messenger where you can ask all the questions that you need to help yourself keep up with or keep on top of questions, or if there's something that slightly confused you, you can get your questions answered. So these are the dates. Please feel free to have a look at them. There's both year 12 and year 13, or AS and A2. So it doesn't matter which you are. We have separate days for each. So feel free to come to both if you are interested, or just one of them if that is all that's necessary for you. So again, you can be in person at Regent's University or on the live stream via Zoom. It's entirely up to you. So we've got physics, maths, chemistry, and biology on these dates. And so if this is something you're interested in, please head over to snapRevise.co.uk/seminars to get more information. Or if you have any questions, please email hello@snaprevise.co.uk and we can give you as much information as possible. There are discounts if you book bulk. If you're a chemist, a physicist, and a biologist, then there are discounts for students like you. So please head over, get some more information, and hopefully we will see you there. Okay, fabulous. Okay, guys. Oh, sorry if it's during term time. That's a bit rubbish. Bad luck. Okay, well, have a lovely rest of your time, guys. Hopefully I'll see you at a future web class. Please keep an eye out on our YouTube channel for upcoming web classes in case it's something you're interested in. And I'll hopefully see you super soon. Awesome. Thank you very much, guys. If you have any questions, then send them over to hello@snaprevise.co.uk and we will see you very soon. Thanks, guys.